But
Actually, it's not Shambhu Singh. I'm his daughter. My name is
yeah,
Anushka Singh, and I'm joining the class over here.
very nice. Thank you. No, that
Um,
we know that many times kids they join their parents get cancer, so that's very good.
yes,
Okay,
sir.
so tell us a little bit more about yourself.
So, actually, my name is Anushka Singh. I study in class 8. I live in Pune, Maharashtra, and
Very
I study in Sri Chaitanya Techno School over here.
okay, very nice, good. Eighth class. Okay, so what kind of science topics you study in school right now?
Basically, we study like we are having NCRTs and we are having a techno portion over here. The techno portion is the advanced one. Like, as I'm in 8th class, they will teach you the syllabus of 11th and 12th class.
Uh,
So, we study both of the things in the school.
very nice. Okay, all right. And Aryan, you want see it's first time. You want to introduce yourself a little bit to her?
Yes, sir. So, my name is Aryan Kumar. My father's name is Naveen Kumar. I'm 12 years old. I'm studying in 7th grade. I was born in Bihar, but I'm living in Ludhiana for my education purpose. So, my dream is to become an astronomer. So, yes, sir.
Thank you. Very nice. And I'm one of the here. You can call it instructor or teacher. My name is Amarnath Sir. I am a scientist, retired scientist, and uh, engineer, and I'm living in the United States. Pankaj, you want to introduce a little bit yourself too?
Yes, sir. My name is Pankaj Kumar Jha. I am also living in Pune, and right now I am doing job also in accounts and finance department.
Good. All right. So, anything you guys want to share? I was watching a video that Makkah, which is in the desert, is flooded with rain. Can you believe that? Makkah and is flooded due to rain. We have unusual weather in this country right now. In California, there is a lot of flooding happening. Maybe Malik ji is kind of keeping an eye on it so he can tell us about flooding there. In all over the world, we see that weather pattern is completely becoming abnormal. Especially the when I saw a flood coming in Makkah, I couldn't believe it. A flood in Makkah. Can you imagine it? I mean, that is the Saudi Arabian desert in ancient time. And um, while Malik ji is introducing, Malik ji, we have gone through introduction because we have one eighth grade student joining today. So maybe you can introduce a little bit yourself.
Yeah, you're asking me?
Yes, we all have
Oh,
done the introduction
oh, I
uh,
see.
because there is a new student today.
Oh, by the name Shambhu?
Yeah, that is her dad's name.
It's okay.
Yeah.
And what is her name?
Can you repeat your name and introduction one more time?
In
Yes, sir.
brief, yeah,
Uh,
yes.
my name is Anushka Singh, and I live in Maharashtra, Pune, over here, and I am also from Bihar.
Yes.
That's that's all. Thank you.
Yeah, and your interest in science? You're
Yes, sir. I'm
interested in
interested in
science?
science. Like, it's my favorite subject over here.
What is your favorite subject?
Science and English.
Science and English. Okay, good, very good. Okay, so as Amarnath ji told that I must introduce myself to you, I think others, I know them already. So my name is Chaturanan Mallik, and I stay in Kolkata in India. And I was part of Bhava Atomic Research Center, and I'm basically an accelerator physicist. But I'm really very much interested in interacting with young people regarding science. So that's how I'm here. And let me wish all of you a very happy new year, which is coming very soon. We'll be having next meeting in the new year.
Thank you.
Hello.
Very nice. Yeah. So now I'm just showing you the picture of this is the Makkah flooding happening there, and so maybe one of the topic we should discuss today is that why is this that weather? I mean, it seems that atmosphere is able to retain a lot more water vapor than before. So what is causing that? But before we do that, let's just have little question answers. If Anushka or Aryan or anybody else has any question.
Amarnath ji, actually, I thought of starting, we had ended the last meeting with the question.
Oh, okay.
Yeah, yes. So I want my young friends to say a few things about that question. The question
All right.
was, why is in summer the days are longer and in winter the days are shorter? What is the reason behind it? Who
Very
wants to
good.
answer? Who wants to answer this question? So I want you all, I think Pankaj has made this platform. Obviously, we are not going to replace your science teachers or your parents. What we want is that you should think about questions which bothers you, and you should come here and we try to discuss. There are many questions I may not be able to answer, but I'll prepare and try to answer. So we want to have an interaction about science. So who wants to answer this question? Our young friends, you can attempt.
Can I go ahead?
Yes.
Aryan,
No,
Aryan,
no.
huh?
Anushka want to answer. So go ahead,
Acha,
Anushka.
okay, Anushka. Yeah, please go ahead.
The days are longer in summer and nights are shorter because the Earth axis tilted around 23 point something degrees in
Hmm.
the orbit of the sun. So the summer is a very hot weather in India or all over the world. So that's why the day are longer and the nights are shorter in summer and opposite in the winter.
Anushka, I want to stop you actually there. No, not stop you. No, you said that India in summer becomes hotter, therefore days become longer. Now, my question to you, there is no relationship between, something becoming more hot and then become longer. What is the relationship?
So no,
If
actually I meant
something becomes very hot, then it becomes longer, is it?
no sir. Actually I meant to say that
Hmm.
uh, the Earth's axis is tilted towards the
Yeah,
sun.
yeah, yes, very much, very much. Go ahead. Then,
That's why the days are longer in summer and opposite in
no,
the winter.
how?
The
That
days,
is what I'm asking. That, yeah, I accept your point that the axis is tilted. So why days become longer in summer?
so actually I'm a bit clueless about it. I just answered what I
Yeah, that
had.
is what. Yeah, yes, you made a very good attempt. I'm thankful to you. I think what we want is that you should be become start thinking as a scientist thinks, because that's what has changed our society. Before 16th century, well, there wasn't much science. It's when people started thinking in a very rational way, objective way, then you see the whole progress has taken place in the on earth. So that is what we want you all to develop this, how to think objectively and with reasoning, with evidence, how to think. Aryan, you want to answer? There are other people are were there. Hello,
Yes, sir.
you want to answer this question?
Yes, sir. So, sir, when the Earth is tilted, one half
Yes.
of the world leans towards the sun, and the other half faces away. So, in summer, our side of the Earth is facing the sun more directly,
Hmm.
and so that is why the sunlight stays for few more hours than the night. I think so.
No, no. Again, you see, again, you are making the same mistake which Anushka has made. That it is tilted, very much correct. So, how the length is period of the day, how does it increase?
Sir, when it when the sun is in the bigger when in when the sun we are facing the sun, it takes a few more hours for the sun to circle back. So I think so,
Anybody else who wants to attempt this? You are both of you are very near to the answer, but yet far from the answer. So, or you want to take some more time? I can give you one more week. I think it's a very interesting question, which we all should know. And I want you to think logically and objectively. Okay,
yes,
you get one more week time to both all of you to understand, try to answer this question.
sir. I think so it's related to some spherical geometry.
Not at all. No, no, no. We cannot make wild guesses. We must make a guess which is looks a little bit reasonable.
Yes, sir.
Yeah. So fear has nothing to do with it.
Okay, sir.
But you are on both of you are on the right track, but just missing the point. All because you haven't given time to it. So once you think about it, you will get the answer. I'm sure about it. And certainly I am not going to give the answer.
Also, if you have any model, you should try, you should attempt to prove it. That is what we call it in engineering, model based problem solving. When, for example, you know, uh, say if I have a problem in the whatever I'm doing, then we sit down and unknown problem suddenly has surfaced in the whatever in the scientific experiment we are doing, unexpected result or defect or anything unexpected, and we don't understand right away. So then we put our head together in the meeting, and then we try to come up with different models that maybe this way, this is why it is happening, this is why it is happening. And then one by one, we evaluate it, root cause analysis. Because if, like, for example, if you see the smoke, then you conclude that there must be a fire, right? So, like that, there is some trace of that thing available, and you have to find that trace to prove your point. So that is what is called model-based problem solving. That you come up with different model, and then one by one, either it is possible or not possible. You conclude it, and then you know you keep removing your model until you come up until you go to the model which has most probably has the answer. So good. So I guess then we will discuss it next week. In the Happy New Year, hopefully we'll solve this puzzle.
Yeah. Now, Amarnathji, you were telling something, showing us about that Makkah
Yes,
flooding.
yes, yes. Yeah, I can show that. Maybe that should be the topic. Why this weather is changing everywhere. We are facing severe storm and all kind of things in the United States this week. And let me open it one more time, and then I'll share. Give me a second. Yeah. So here it is coming. It will come in a second. Yeah. So as you can see it is a desert. Saudi Arabia is a basically desert country. They don't have uh, very little rain. I don't know what is their rain level, but it is pretty much unusual to see this kind of rain which has caused the flooding. This is not the water coming from the river or something. It is because of the rain, outpouring rain, and then whole Makkah. In fact, their Kaaba is. They were afraid that even the Kaaba will be washed away. Their religious center. I was watching comment. They were saying, "Where is Allah? He cannot even save the Kaaba." That was one of the questions. So we need to understand what is happening right now um, in our atmosphere, that which is causing the weather change everywhere on different continents. I already gave you example of that. Right now we are having a lot of issues in this country, California, which is also kind of semi-desert. Flooding is happening there. Northeast, where I am, a lot of things, snow and rain, storm we are facing right now. In fact, this morning we had a snow. Maybe I'll show you a little bit later from the window, the snow flurries, which is probably still happening. But look at this here uh, in Makkah. So I have a question for all of you to think. What is, I mean, it means that our atmosphere is retaining somehow more water vapor, and then it is becoming under some kind of atmospheric pressure change. That water is released suddenly on the ground, causing all this flooding. So I would like to see what is the model, what is happening. Maybe all of you can think about it, and we can do the analysis. Thank you.
No, actually, the primary reason of the weather change is that, if there is even a half degree centigrade change in the atmosphere, what happens? The water which vaporizes from the sea changes, and it has got that has an implication all over the earth. But as far as Saudi Arabia is concerned, I was not keeping track of it. What was the reason that why they got so much? But certainly these are the disturbing. This time you see in Kolkata, we have got the coldest winter in last 15 years.
Mm.
As you can see, I'm wearing a sweater, which I never do. For the first time in 5 years, I'm wearing a sweater. So in Calcutta, we have got very cold. It is 12 degrees centigrade in the night.
Wow.
So, uh, so people are really enjoying. But of course, what has happened that wherever there was functions were there, song functions and cultural functions, all that. Just because of the winter, people are not going out of the house.
Yeah. So tell us that I can understand that part, that more water vapor is coming out of ocean to the atmosphere.
And surprising thing is that even half degree centigrade makes a big difference.
Yeah. But
That
then
is why.
then how does it precipitates? I mean, why it doesn't stay in the atmosphere? Why does it become the rainfall? So explain that.
No, that is the regular process of how the rain happens, but the uptake uptake of the water vapor, it changes very much. Like say in this time there was a El Nino and El Nina in India. That was just related to the water uptake which took place on the equatorial lines. That happens. The details are there. The details are there how it influences, but it does influence all over the earth actually. And of course, uh, I should not say much. I don't know much about it. Maybe then, but that is the main reason actually. The slight temperature change causes this.
Okay.
Maybe Aryan might be knowing a little bit. Hello, Aryan.
Uh, Sir, I think I have a little idea about it. So what I think that when like the glaciers melt, snow is the most reflective thing on the planet. So what happens
Mhm.
that when it uh, when it is converted into water, uh, more ice melts because I think so CO2 is also being released.
Mhm.
And so that is why we have global warming and it is increasing exponentially.
No, Aryan, I have some. What you're what you're saying that the ice melts. So ice melts. Okay, so that forms into water.
Yes.
Yeah, of course, that does happen. But then, why CO2 comes into the picture? I don't know.
Yes.
I mean, it's not evident to me that you might tell what is the relationship of CO2 with this.
Okay, yeah. Can I add something to this? I just heard a part of the conversation why CO2 comes out of when ice melts. When the ice freezes, the CO2 gets trapped into it. So when ice melts, the CO2 which was trapped is now released.
Yeah. So what Aryan is saying that when CO2 is released, so that causes warming of the weather.
It goes into that cycle because once the CO2 is released, there's more warming means more ice will melt, and more ice melts, more CO2 get released. So that triggers a cycle which becomes difficult to reverse it.
Okay, maybe yes, you may be correct because there is more CO2. But is that what explains the turbulent weather that we have all over the earth this time?
No, actually, there are multiple factors. Melting of ice is just small fraction of it
Yeah, that is what
because
I
the
thought. So. Hello,
yeah
someone was trying to ask a question. What is that? No. Yeah, please go. Please go ahead. I think. Yeah. What happened?
yes
Yeah, please go ahead. I think we want to hear from you.
you are someone is asking question or you want me to
No,
answer?
I think nobody was asking. That was some sound which came. I don't know from where.
Okay,
Yeah, please
so
go ahead. Yes.
okay, so one other thing, there are multiple things that happen. One is the weather, which causes the wind flow, which causes the movement of moisture from one place to another, and movement of air around the globe. Now, what is happening is the Arctic is getting warmer at twice the rate as normal one. So the airflow, which was nominal, that is the jet stream, which we call it, which to move from west to east or westerly jet streams, which was regular because of the temperature difference between Arctic temperature and the subarctic temperature. Now, because the temperature difference is reducing, this flow, the laminar flow of jet stream is getting turbulent. It starts dipping towards the southern, or I'll say towards the equator. Now, because it's happening that way, now any flow of air is happening from place of high pressure to place of low pressure. So wherever you will find the jet stream is coming, is creating a low pressure there, and there is high pressure on the northern side. There is a low pressure on the southern side. The more it dips, more erratic weather is creating. So the temperature difference because of the global warming is happening. The next is in the Atlantic. There is something called, I don't remember its full name. AM is called AMCL, I think. Atlantic Meridian Meridian Transport. Yeah, Atlantic Meridian Overturn Circulation. Now, what is happening is because of snow melting, there's a lot of fresh water is being added. So, what is happening in the sea? The water is salty, and when the ice melts, water is less salty, or there's very little salt into it. Now, because of this, and that normally what happens, the cold water sinks, the warm water moves up. So the whenever there is a circulation of water that takes place, the warm water from equator goes towards the Arctic, which is we call it Gulf Stream, which creates a warmer weather in Europe compared to eastern part of USA. And same thing happens in Pacific also. So the eastern part of any landmass is colder than the western part of that landmass. Now, because of this water difference, because of this temperature difference, what is happening? That is called as thermohaline forces, which is temperature and salinity. Because of this, they are saying the belt itself is getting destroyed. The belt is important for multiple reasons. One is it moves the warm water to the bottom of the sea and takes the cold water from top to the from the bottom of the sea to the top. That circulation is also stopping. So because of this, what is happening is the cold water which was supposed to sink in and the warm water is supposed to move up, that is also stopping. It creates problem not only for the weather, it also creates problem for the food chain, because any human being or any creature which can get anything from food, the body does not produce. So a lot of the smaller creatures which are found at the bottom of the ocean will not be thrown up and will not be eaten by intermediaries and final consumers like us. So it's not only going to create problem just for the weather, it's also going to create a problem with our nutritional requirements. So you may be eating a fish, but fish may not have the required nutrients which they would have eaten from other organisms, and because of which we may eat fish, meat, whatever it is, but the basic ingredients will be missing. So these are other problems which will be created. The third problem that will come up is lot of bacteria, they have ability to survive at very high and very low temperatures. Now with the melting of ice, what will happen is lot of such bacteria which are trapped in the ice will be released, and once they are released, they are going to reproduce at phenomenal rate. So now what is going to be the repercussion with those bacteria? We are not learned to live with them. The moment they come, that is also going to create problems. So if you notice all this, melting of ice and rising of sea is the least of the problem. There are other problems will come up with this.
Oh, thank you very much. I think you have given quite a detailed picture of what's happening. Thank you very much.
You're welcome.
So, Anushka and Aryan,
Let's see if they have any questions for Udayji. Yeah, Aryan or Anushka, if you have any additional questions about this weather change, please.
but Udayji, question was from Amarnath ji that why there is so much rain in Saudi Arabia. Hello.
Yeah.
Udayji, there was a question from Amarnath ji that why there is so much rain in Makkah and Medina. I don't know, is it a problem with my mobile or there is something?
Oh no, no, we can listen to you. Maybe he is muted right now. I can see that.
Sir.
Yes, sir.
No, sorry. I got disconnected and my mic was mute.
Yeah, yeah,
Oh,
yeah.
Okay. So, yeah. So, the sub-Sahara region, which is desert today, was not desert every time. There was a greenery in that particular place. Now, a lot of things happen because of the tilting of Earth's axis. It's not just the rotation and revolution. This the tilt of the Earth axis also changes. We call it, I think, nutation. Okay. So because of that slight tilt that keeps changing, the places which are greener become desert and vice versa. Now, because of those changes that is taking place, the regular flow of monsoon is also getting disturbed. Normally what is supposed to happen is the like I'll talk about United States here, and India has a different phenomena, United States has a different one. Now what is supposed to happen is sub-Sahara gets heated up, the airflow moves towards the west, it carries the moisture, brings it towards the next landmass, which happens to be the American continents, and that's where the rain happens. So most of the rain normally happens on the eastern seaboard most of the time. That's the regular thing. Now India is different. India has more rain because of intertropical convergence zone. Now intertropical convergence zone is basically, I can call them as solar equators that moves north and south of the equator based on the movement of sun. So during winter it goes to in southern hemisphere, during summer it comes to the northern hemisphere. So there's a belt of low pressure. Now that belt of low pressure actually carries, because it has a low pressure, it gets the moisture from places of higher pressure which is outside the belt, and as these things move, they carry rain along this. We also call it the northern limit of monsoon. Based on this, it has a rain till time it the belt moves all the way to Bangladesh and this thing, when it loses contact with the moisture. Similar thing must be happening in those places also, where low pressure is being created, which carries moisture from the sea and dumps it in the next landmass. The moment there is a disconnect from the uh, water, it is going to drop, because the low pressure requires water to be pulled up every time. The moment the water connects, stops, it starts pouring the water.
oh, I think you have given a very detailed picture of the whole thing. So, Anushka and Aryan, do you have any question regarding this?
No, sir.
No,
Now,
sir.
do you have questions?
Yes, sir, I have one of them.
Yes, go ahead.
So, how did we measure the age of the Earth?
Okay, so actually there is no direct measurements, there are only indirect measurements. So now what has happened is there are different things like uh, metals which are being measured, how they've been created, when they would have been created. All this actually leads to the trying to determine how the age of the Earth has been calculated. How much time does it make for one particular? Most of things are based on radioactive substances dating, radiometric dating. So how much time it takes for one particular uh, element to fuse with another element, or fission of that element to be created something.
Oh,
So I could just add a little bit to it, but the question is still, I think, is a very good question, Aryan. I want to know the exact method by which the age which they call it for about 4.5 billion years, how it was measured. But what Udayji was talking about is the radio carbon dating, and there are other dating methods are there. But the radiocarbon dating is that, there is in our human body or anywhere,
Oh, yes, sir.
there is a ratio of C14 to C12. The normal carbon is 12. There are 6 neutrons, 6 protons.
Okay, sir.
And there is a C14 also. So this ratio, and once a body decays, as long as the body is alive, the ratio remains the same. But once it dies, the ratio starts changing. And the decay, it has got a half-life. So from the half-life, how many half-lives this ratio change has taken place, you can make out what is the age of anything. So that is how this is applied to I think about not more than, you see, but this is dependent on the living organisms. Yeah, but I think the age of the earth cannot be measured by this method. There has to be some other method. I don't know. I think I'm going to look into this question and answer you next time. It's a good question. I just never thought about it. Or Udayji, you happen to know?
No, it says that.
Radiocarbon dating is for few million years, not more.
No, I'm saying there are elements like zircon crystals. Now they have calculated the age of that as 4.4 billion. They are saying that the oldest one. If they find something new, some other items, the age may further change.
What is the basis of that calculation? Like say in case of carbon, you have got the ratio which changes.
Yes.
So because it has a half-life of few thousands of years, so from that you can make it out. But in case of other methods, I still don't know actually. Maybe I will look into it. Thank you, Aryan. This is a question. Yeah, it should have come to my mind. Or maybe Udayji, if you know some answer, then you can tell us.
I think I'm looking at one of the picture here. It says the same thing which you just mentioned, that two isotopes, somehow their measurement is related
No,
to
that is,
explain.
with that you can measure few million years. That is how we have measured, most of the things which we have now. But in case of a billion years, it's not effective. It's not correct, because when there were no living organisms, we cannot measure this ratio.
Sir, I think so. I have one answer.
Yeah, sure. Please go ahead.
So, sir, if we take very old rocks
Hmm.
and see how many layers there are in this rock, and if you know uh, how much time it took to create one of the layers, we can find out what is the age of the Earth.
Uh,
So,
my
so
understanding is that even the rock formation, because earlier times, it was, yeah, lots of volcanoes and the surface was not rocky.
Yes.
So, there will be huge error in estimating the age of the universe. So only when it has solidified, then the layers will tell you, yes, that is how they do it. From the layers, but how do we say, your question was, how do we say that the earth is 4.5 billion years old?
Yes, sir.
This is a good question.
So,
Anushka, you have a question?
no, sir, actually, I don't.
How come you don't
No,
have any question? Means, do you understand everything?
Yes, sir, I'm trying to listen everything over here, what you are trying to explain us. So just by listening, I'm trying to.
So my question to you is that in your house, what you see everything, do you understand each one of them? I don't understand even half of them.
No, sir, not everything.
Yeah, so what is it that you don't understand? Anushka has been caught. Amarnathji, Anushka has been caught. So you don't understand everything. So what is it that you don't understand in your house or around you or around you?
So there are so many things I don't understand over here, like around me happening, but I'm just trying to understand whatever you guys are trying to explain and the questions and all.
Okay. No, you must
Yes.
be, yeah, whatever you see around you, you must be a bit critical about them, try to understand them, why it works that way, why it doesn't work that way. So that's how science progresses. When people started asking questions in 16th century, and that's how science developed. Till 16th century, people had stopped asking questions. Whatever they were told, they just believed it. So all the progress which has happened, it's because we are asking questions and we are demanding answers.
Actually, when they're talking about, can you hear me?
Yeah, yeah,
Yes,
you
we
are
can
Yeah.
good.
hear.
So whenever they're talking about radioactive measurement, they're talking about uranium. Now, there is some phenomena which has happened when the two planets collided. One of them, I think, was Theo, which collided with Earth. And because it collided, multiple things happened. One is the temperature of the Earth went up. Other thing was the debris of that particular collision, they started revolving around that Earth, which got collected and became Moon. So the lot of change, because the Earth was actually boiling, lot of changes took place in Earth rocks, but same thing did not happen for the Moon rock because they were created from the same debris like Earth and Moon. So by doing the carbon dating of the Moon rock, trying to find out the uranium and other uranium, rubidium, there are other metals which are heavy metals. By calculating their half life, they have come to this age of 4.45, 4.46 billion years ago. That's how that calculation has been done. So it is same radioactive, but they are trying to do of heavy metals, their half life, and based on their half life, I think they have come to this conclusion.
Okay. So we have now Shreya Jha. Pankaj ji?
Yes, sir. Yes, sir. Yeah,
Good
please
evening.
introduce yourself. And if you have any question or want to say something more.
Yes, sir. Last time you asked a question.
Yes. And where is the answer?
Yes, the question was that in winters nights are shorter, nights are longer, and days are shorter. What is the reason behind this?
Yeah, correct. Good. Please go ahead with the answer. Yes.
Sir, so the reason behind this is because the Earth's axis is tilted. That
Okay.
causes your hemisphere to point away distance from the sun, receiving less 25 point, receiving less direct sunlight from being exposed to it for fewer hours as it
No.
travels
Just
its
just
yearly orbit.
just hold on here only. So it is tilted. So how does it how does the period of sunlight increases? It is tilted. So what?
Sir, can you repeat your question?
No, no. The question is same. I'm asking about. I'm asking your answer. Actually, you are saying that because the Earth axis is tilted, so there is sunlight changes. But how does it change the time period for which the sunlight is there? That was the question.
So actually, during winter,
Hmm.
hemis in the northern hemisphere, in times of winter,
Hmm.
it is tilted far away from the sun. So that's the reason we can means the rays that our sun
Mm-hmm.
gives becomes for a shorter period. Hence, dark the moon comes. The moon
No,
comes.
no. No, there is no role of moon in this one. No, but I would request you that if you have a globe in the house, and just try to see and shine a light on that, and then rotate the globe, and then just see what happens to places near the poles and near the equator. What happens, and you'll get the answer. Do you have a globe in your house?
No, not at all. I don't have.
Oh, you don't have. That's okay. You can borrow from your friend,
Yeah.
and yeah, and then you shine a light on it, and then you rotate it, and just see what happens. For how long on the equator? How much time
Yes.
this light is there, and near the poles, how long the light is there? You will just see it yourself with your eyes.
Okay, sir. I'll do it.
Yeah, please try using a globe and then see it.
Okay, sir.
Aryan has a question. Yes, Aryan.
So I have a question.
Hmm.
Why does a photon have no mass and why does it have momentum?
This is yes. So, oh, this is a question which is deep. Why till date I know but that it doesn't have mass, but why it doesn't have mass, I don't know, Aryan. This is a very difficult question for me.
Yes. So, sir, I have also heard that
Yes.
momentum is the product of a mass object's mass and its velocity, but the
Yes.
photon has zero mass. So, why should it have this momentum?
Yeah, because the momentum is also defined by, see, the energy is defined by h nu. H is the Planck constant and nu is the frequency. So,
Oh,
so
yes.
and the mass and the momentum can be derived from that, because energy is equal to twice half mv square. So energy is there, but energy is h nu and not half.
Okay, sir.
So anything that has got energy has got momentum. But your question is why it does not. No, I don't know particularly why it doesn't have mass. Only we know that there are particles which have mass, and there are particles which have no mass.
Oh, okay, sir.
No, I'm sure this is a question you may, when you become big, then you may have to answer.
Yes.
Why we have so many kinds of particles? Why some particles have different nature? What defines them? It's only now that we know that anything that has got something to do with Higgs boson has mass. Like we all have got something to do with Higgs boson, so we have mass. Photon doesn't have anything to do with Higgs boson.
So, yes, sir. I have one more question.
Yeah, what is that?
So, when an electron is in an orbital and when it absorbs light and photon, so the photon also has momentum. So, does that electron gets displaced from its orbital?
Yeah, that is what the picture is. Right now we try to understand this picture. It has got stable orbits, and so when it absorbs, it jumps to the next orbit.
Oh, yes, sir. So,
That's what the picture is. But it's a complicated picture because that electron, once you start imagining that it is a wave, it is a wave packet, not wave, but wave packet. And then the picture is a bit complicated. But then all we must now start thinking in terms that something can be a particle at times and wave at times.
Okay, sir.
This is where our understanding of quantum mechanics is still very limited. Maybe in future we will have a better understanding of it.
Okay, sir. So, and one more, sir. Why are things transparent?
Now, what is your guess about it?
Sir, I think so. The spaces between the photons travel are very big, and so the photon does not interact with any of the atoms.
No, no. Here you got you. In fact, the answer lies in your last question. Actually, see, when photon crosses an atom, it's not necessary that it will absorb. See,
Yeah, okay, sir.
if the energy is very near to the difference between the orbitals, then it absorbs very near.
Okay,
Otherwise, it doesn't absorb at all. Just the photon just goes through.
yeah, okay, sir. So, sir,
Yeah.
when an electron
There is
goes,
one statement just now Aryan has made. You'll be surprised. They say that you see an atom is so much empty space that if all the space is filled, so that there is no empty space, then the whole of Earth can be put in a spoon. Amarnath ji, अमरनाथ जी आपका ये है.
Please unmute, sir. Yes, sir.
Okay, what you are saying?
इतना कम इतना an atom has got so much empty space that if all the matters are condensed so that there is no space left, empty space left, then the whole of Earth can be squeezed into one tablespoonful. So there is so much of empty space.
Yeah, I think that is how the structure of everything is. Atom has a space. The space has a space in between the planets, right? It's pretty much the similar pattern. We see it in everything. If we take any element, there is a space in between uh, their their atoms, right?
Yes. Yes. So Aryan, you are asking a question. Sorry, I interrupted you. Yes. Please go ahead.
sir, when an electron goes very near an nucleus, so if it moves away from it, so will it lose, like, it will lose the kinetic energy, so where will it go?
No, no. So when it approaches, it gains in kinetic energy, and when it goes away, yeah.
No,
No,
sir, it will lose kinetic
whatever
energy.
happens by the electrostatic force, there is only one force which interacts between them, electrostatic force.
Okay, sir. So, sir, the opposite charges attract, right?
Yeah, they attract.
So, sir, wouldn't the electron lose any kinetic energy here?
Hello?
Yes, sir.
Yeah, sorry, what is it that you asked? Sorry, I just missed it. Yeah.
Oh, yes, sir. So when the so sir, the electron will lose its kinetic energy, right?
Right.
So, sir, where will it go?
No, first when it approaches, it gains in kinetic energy. So it is a simple positive charge particle and negative particle attraction. or you can say similar to like say a meteorite approaching Earth. The same thing happens there. Just as a meteorite approaches Earth, whatever happens will happen to the electron and the nucleus. Because the only force which is there is the Coulomb's force, which is very similar to the gravitational force.
Okay. So my question is, when the electron gets very near the nucleus, it will get attracted and it will
It will
deviate.
increase in energy. It will kinetic energy will increase, obviously.
Sir,
Yes, I agree.
sir, how will the kinetic energy increase?
Why not? Because there is a force acting on it. So whenever there is a force acting on it, the Newton's law says that its energy must increase.
But sir, it will deviate from its path and lose the kinetic energy.
Yeah. So now whatever was gained will be lost.
So sir, where will that go?
No, but suppose I take a classical model and suppose an electron is approaching the positive charge. So it just goes and it's just like a meteorite which approaches the Earth. The same
Sir,
thing will happen. Similar situation it is.
sir, I'm not getting how the electron will gain the kinetic energy.
Look, electron gains in kinetic energy because something which is falling in an attractive field, there is a force acting on it. So
Okay.
whenever there is a force acting on it, there is an acceleration produced. And there is an acceleration produced means its kinetic energy increases. And whenever it goes away from it, it loses in kinetic energy. Or it can circle the atom. The
Yes.
classical model, I'm saying, the classical model.
So sir, if the electron stops, it will orbit the atom. So
If
what
the
happens?
electron will stop, then it will impart that energy to the nucleus.
So sir, how will that happen? Will it just create photons?
No, I mean, we were talking about the classical models.
Oh
So,
yes.
yeah, but the atom and the electron, they don't behave classically in that sense.
So Malik ji, I thought that electrons are orbiting in the certain cell, as per Neil Bohr's model, right? So if you
Yeah,
move from one orbit to another, I forget the physics of that, but there is certain level of energy which is needed to move, or energy is released to move from one to another orbit, right? So how can this freely move in center? I thought it had no choice but to stay in the orbit, isn't it?
yeah. So Neil Bohr's atom was that electron goes around the atom, but there was a flaw in it. The flaw is this: that Maxwell earlier had proved 200 years back that if a charged particle accelerates, it will emit radiation. So an electron, when it is going in circles, it is also accelerating. It is a case of acceleration. So it must lose energy. So once it loses energy, its radius will keep on shrinking and finally jump on the nucleus.
Mm.
The radius will continuously keep on decreasing and finally it will hit the nucleus. That was that was the flaw with the Niels Bohr, and that's why the quantum mechanics came. That this rule doesn't apply to the atom.
Yes, sir.
So here, doesn't it mean that if this is true, then continuously all the electrons will start kind of merging into nucleus, isn't it? Now, what you are saying is that they have a tendency to merge into nucleus.
That is what Niels Bohr's atom was
Thanks,
supposed
sir.
to become. But that's not true. That's how the quantum mechanics explained that electrons, they are in a orbital, they are wave functions, and they are in the orbitals, and they are not losing energy, they are remaining there. So the stability to the orbits was given by the quantum mechanics and proved that the Niels Bohr theory was wrong.
Someone has raised hand. Let's see who is
Some,
that.
Yeah.
Okay. Yes. You have a question? Please continue your question.
Yes, Anushka, please mute.
Yes, Anushka, yes, please ask the question.
So basically, when a electron loses its kinetic energy, it does not fully loses the kinetic energy, right? Like it transforms. It can become a light, like photon, heat, or any potential energy, like depending upon the interactions.
Sorry, I did not get your point actually. Electron does not lose energy.
So
No,
it does not fully
first of all,
loses the
we have got to think electron as a particle and electron as a wave packet. So now we are discussing electron as a particle. Yes, and now go ahead.
So I was saying that electron does not loses the full kinetic energy of its like the energy is converted into other forms.
Yeah, sure, sure. So, yes, sure. Yes.
So that
Very
is the
true,
point
very
I
true.
wanted to speak about that.
Just like a stone, if it drops, if it is at the top, when it goes away from the earth, so it gains in potential energy, and when it falls down, it gains in kinetic energy.
Yes,
The
sir.
same thing happens to the nucleus and the electron in the old classical model.
Yes, sir.
But
yes, sir.
yes, go ahead.
So, sir, when I was asking the question, we can
Hmm.
imagine has like a car suddenly braking. So, what would happen that the extra energy would go to the tires or make a sound.
Yes.
So that is what is happening with the electron. So, when it will go near the nucleus, it will lose lose the kinetic energy and
No,
get it in
no,
some
no.
form.
An electron is negative. Suppose the classical model only. Suppose the positive charge is there, and an electron is a negative charge is there. So when if electron will be attracted by the Coulomb force, so it will gain in kinetic energy. No, while approaching the nucleus, it will gain in kinetic energy in the classical model.
Uh, Sir, I think so. It's called breaking radiation. So it says something like when the electron gets near an nucleus, what would happen that it will release photons to make up the lost energy. So I think so. That is what it is called. Yes.
Yeah, yeah, yes. So yes, so electrons, no, that is the interaction of the electron with the electron of the atom. So it imparts energy to that, and there is a change. That electron which was there in the atom jumps to the higher level, and then again comes down emitting light, emitting photons.
No, sir. It's not like it's the thing that you were saying. It's the spontaneous emissions. So breaking radiation, what happens that when a free electron is traveling through space, and if it gets too close to an nucleus, what would happen? It would deviate from its path, and to make up for that lost energy, the electron will just create photons uh, that match their lost energy for the equivalence of energy, and that is called the breaking radiation.
Also not, so what you're talking about is that an that is the when a charged particle moves in an electric field, means when there is an acceleration in the charged particle, no, it emits photons by itself.
Yes, sir.
See, the one is we had a synchrotron in Indore. There, they do experiments with the electrons, means photons emitted by accelerated electrons. The whole center in Indore, which is a big complex, about 1,000 acres in complex, has got a synchrotron. In the synchrotron, the electron moves round and round, and because it is an accelerated motion, it emits photons. And people study those photons or interaction of those photons with materials. So the whole accelerator is based on this principle only. This is called synchrotron radiation because it's emitted in a synchrotron. But anywhere, if the electron gets accelerated, it will start emitting photons.
Okay, sir.
And that was the flaw in the Niels Bohr thing. They said that if the electron is going round and round, suppose the electron approaches and it gets captured and it goes round and round, then it
Yes.
will emit photons and lose energy and finally collapse to the nucleus.
Yes, sir.
But that doesn't happen. So therefore, the Niels Bohr theory was rejected. But then it explained many things, but didn't explain all the things.
Yes, sir. So, sir, I had one more question.
Yes.
Sir, have you heard about the principle of least action?
Yeah, I have heard. Yeah.
So, sir, why is it true? Why should nature care about minimizing the action?
Well, Aryan, frankly speaking, I was told that the nature likes to behave that way, principle of least action, rather than. I still don't know why. I don't know why.
Oh, yes, sir. So, sir, I have read a little about it. So, I think so. It has to do something with the phase. So, phase, uh, you can say like it is the measure of action, time, or an energy. So, uh, when a particle wants to travel like from path A to B,
Hmm.
all of the very crazy paths phases cancel each other out, and the things that are remaining they constructively interfere to make up that path. So I think so. This has to do something with Feynman. Feynman, this person. So yes, sir, this is what I've read.
Hmm. I won't be able to comment on this one, but the principle of least action, as soon as you enter the honors course in India, you will be first lesson that will be taught to you is the principle of least action.
Okay, sir.
And that's how nature behaves. They will talk to you about Lagrangian. It is the L integration of L dt, which is called the action. So that always remains the least.
Okay. So, sir, what is this unit of action? Is there any SI unit of it?
Yeah, what was the SI unit of action? Actually, I don't remember. Maybe next time I'll tell you. I forget this one. Sorry, Arini. You can figure it out somewhere. I have just forgotten.
Yes, sir.
SI unit of action. I didn't get the question. Can you
Uh,
repeat? Or
Aryan is asking, no, in classical mechanics, there is something called action, which is defined, which is very, roughly defined as Lagrangian into time. So, uh,
Yes, sir.
the nature behaves in such a way that it always remains the least, the quantity. If something travels from place A to place B,
Yes.
this quantity will always remain the minimum.
Okay, sir.
This is
So,
the this is how the nature behaves.
yes. So, one more thing I've read about it, that all of the particles uh, in fame, what Feynman did, that he took all of the paths to be weighted equal, so each path has the same probability. So it means that the particle is going through all of the is it means like it's exploring all the possible paths to go to that place, but the the paths with the phases that are most similar to the principle of least action constructively interfere and make up the path that we see. So, yes, that
Uh,
is
uh, no,
what.
Aryan, actually, suppose from point A to point B, there are different ways of going, different paths you can take.
Yes,
But in nature, a particle will take that path where the action is the least. This is what the principle of least action is. Suppose from your place, Ludhiana to Kolkata, there are many ways you can come. You can come via Chennai, you can come via Kashmir. There are many paths. But then the path which has got the action least, the nature will follow that path.
yes, sir. So, I
हम
think
लोग भी
so.
हम लोग भी करते हैं ना कि यहाँ से अब लुधियाना जाना है, आई विल टेक द पाथ विच इज बहुत कम समय में हम पहुंच जाए वहां पर. आई वोंट गो भाया चेन्नई, इजंट इट?
Yes, sir.
So that's what the particles also do
Yes, sir.
intuitively.
Yes. So, sir, I think so. This also shows up in the double slit experiment. So, like if we add infinite slits, so we will just take up the amplitudes of them, and I think so. We have to square it to get the probabilities. And
Hmm.
so this is where this action came in. So it's all started with the double slit experiment. Yes, sir.
Yeah. Yeah, double slit experiment is something which is very, very interesting. I would request all of you, when you go to some class 9, 10, or something like that, you'll have a, or in the honors course, you'll have a detailed understanding of this one. But it is a very nice experiment.
Yes, sir.
It is a very nice experiment which was done.
So, uh, so one more question. Uh,
Hmm.
I have heard about sir, I have
Hello.
heard about quantum decoherence, and I've also heard about wave function collapse. So, in wave function collapse, what happens when we measure, let's say, a particle? What will happen? That its wave function will collapse and it will go to a specific point. So, and its superposition will get cancelled. So, I don't see the difference between this quantum decoherence and wave function collapse.
The question is too difficult for me, Aryan.
Oh, okay, sir.
I think we have already gone over the time, so maybe
Yeah,
we should save some questions for next time.
Yes, sir.
yeah. Udayji, do you have one question for our young people as a homework?
I think listening to their argument, I found that most of the problem is coming up because we are trying to view quantum mechanics from the classical mechanics lens. So because what is happening is when we were didn't have the required instruments or to measure more accurately the speed of light and other things, we are looking at objects which are slow moving. So minor calculation error was never found out. As we found better equipment to measure it, our most of our calculations were found wrong. So classical mechanics, a lot of things get proved wrong because there are other factors. I was talking about one particular day. The constant is something which you don't know what is happening, so you just put a constant. So because of those particular thing, which was when they started measuring things more accurately, they found their calculations were not adding up. Every time they're getting different errors. So they found out, okay, there are other things which is affecting it. The other thing which was affecting it is what created quantum mechanics. So if that additional factor that you see because of because electrons and other things are moving at the speed of light, which was not happening when they're trying to study planets or solar systems. They were not moving at the speed of light. So there were no requirement to add additional correction factors, whatever you want to call it. So if you keep talking about things from classic mechanics point of view, there will be error in understanding quantum mechanics. So quantum mechanics, you have to first erase classic mechanics and look at from a different perspective. And regarding, you're asking me to ask a question?
Yes, homework for our young people.
Okay. You know that Earth is tilted an axis of 23.5 degrees. Now, the moon is also tilted to certain axis. Okay. Is that axis fixed or it keeps changing? And if it's changing, why? The axis of the moon with respect to the Earth.
So can you repeat the question?
I said the axis of Earth with the our solar with our orbital, the Earth axis is tilted at 23.5 degrees. Am I right?
Yes, sir.
Very good. Yes.
Okay. Now moon axis also will be tilted with respect to our axis, our orbit. The moon is also rotating around the Earth. Am I right?
Yes.
So that would be also tilted.
Revolving around the earth. Yes.
So that will also be tilted to a certain extent. Now that tilt is supposed, is that tilt is constant like 23.5 or it keeps changing? And if it's changing, what is the range of the change? And why it's changing?
Very
So
good question.
how
Kids
did you?
will have to think and do a lot of research.
Yeah.
I think
Yes.
they will need at least 2 3 weeks to come up with the answer. So
Yeah,
take whatever time it takes. But I
I'll
would
just
recommend that when you have answer, please present it in a PowerPoint or some kind of presentation, not
Yes.
only the talk. Okay, whenever you guys are ready.
Sir, I have one guess.
yeah.
So, sir, when the moon is in a specific position, it is getting influenced by the sun's and the earth's gravity. So, when it is near us, what would happen that the earth's gravitational pull is strong and the uh, axis would be tilted toward us, and when it's a little far away from us, the sun's gravity will make it uh, fall the axis towards it. So this is my guess, sir.
No, that's true. The everything in this universe or everything are being pulled by various things. So I said that even Earth's axis keep changing, and we call it nutation. It keeps nodding. Okay. So
Yes.
moon axis also have to keep changing, but change of moon axis is quite fast. Okay. So moon axis is tilted to Earth's axis by around 6 degrees or so.
Okay, sir.
So the moon axis will change from 23.5 minus 6 to 23.5 plus 6, roughly around 18 to 28, 29 degrees. It will change. Why this change is happening?
So, so Udayji has given you a question, and there is one question about the winter and summer. So you have two questions to answer next week in the new
Okay,
year.
yes, scientist. Yeah, lot things on your plate, and that is why it's very important to bring some more friends. The more
Yes, sir.
scientific force you have, better probability of getting it answered. So start inviting your friends to come and join us.
Okay, sir.
Yeah, Pankajji, are you there?
Yes,
I
yes,
think
sir.